Okay, is this going to work? Let's have a go. Right, so the first ones that we're going to go through are the questions that didn't go particularly well on the last progress check. First one is parallel lines question. So you can see here the diagram shows 3 parallel paths with a cycle track connecting them. So we've got 3 pairs of parallel lines there, and we've got this one line which is intersecting all 3 of them, and another one which then creates this triangle. We need to find the size of the angle marked Y, which is down there. At the moment, we don't know any of the angles there, so we have to work out how to get here using the information that we have with the angles up here. So we can see that we've got a straight line, and on that straight line we have a 145-degree angle, and the angle property we need to be able to recall is that angles on a straight line add up to 180. So if we take that away from 180, it will give us the interior angle there, which works out to be 35. That then gives us 2 angles inside a triangle. So I need to know or recall that angles inside a triangle add up to 180. So when I add those up and take it away from 180, it gives me this angle, which is 65 degrees. Now that I know what this angle is, I'm getting closer to transferring to here, because this group of angles here is repeated via that intersecting line down here. So there are various ways to get there, but I know that I've got this 65-degree angle here, which lies on this straight line, which means that angle and this angle in here have to add up to 180. So if I take that away from 180, it gives me this angle. And then I've got the Z. So if that's 115, Y is also 115 degrees. So the angle Y is 115 degrees. Box and whisker plot. So here we've got a box and whisker plot, and I've identified the key parts of it. Which letter indicates the maximum value? Well, the maximum value is at the far end of the whisker, so E is the maximum. If the maximum value is 40 and the range is 22, what is the minimum value? Well, the minimum value is here, A. So the difference between A and E is 22. So if E is 40, then if I take 22 off 40, it'll bring me back down to the minimum value, and that's going to be 18. What is the name given to B? So B is the lower quartile, C is the median, and D is the upper quartile. So B is the lower quartile. If B has the value 25, and the interquartile range, IQR, is the difference between the lower and the upper quartiles, what is the value of the upper quartile? So it's going to be 10 more than the value of B, so it's going to be 25. Sorry, 35, 25 and 10. So that would take us to D. What fraction of the data lies between A and B? So the 1, 2, 3, 4 parts on a box plot, so between A and B, B and C, C and D, and D and E, all represent 1/4 of the data. So the fraction between A and B is a quarter, and it's the smallest quarter. Between which letters do the largest half of the data lie between? So if we're traveling from A to E, we're going from small to large. So the largest half of the data, that's a quarter, and that's a quarter. So the largest half is from C to E. So as I've said there, remember each section of a box and whisker plot represents a quarter of the data. So here's another box plot which is showing multiple box and whisker plots and an additional dotted curve And the key up here is showing you that the dotted curve is the mean, and it's also showing you the various parts of the box plot. So we get the minimum value, the lower quarter, median, upper quarter, and maximum value. Which month has the greatest mean flow? So the mean is the dotted curve, so we're looking for the greatest. So where is that at its maximum? And you can see it's at its maximum there, which is in May. The smallest range. So the range is the distance between the maximum and minimum values. So we're looking for which box plot has got the smallest gap between the max and min. It's down here. It's going to be February. The greatest interquartile range. So the greatest interquartile range is going to be the one which has the largest box, because the interquartile range takes you from the lower to the upper part of the box. So the greatest interquartile range is May. Okay, then we've got reverse percentages. Now today's test is a non-calculator paper, so if you revised this work, there were two different methods for this, one which is a non-calculator method and one which was where you were allowed to use a calculator. So for this one, Jacob buys a watch costing £84. This cost includes VAT at a rate of 20%. So it includes the VAT. So that £84 already has this built into it. How much is the watch without VAT? So with the without part is the original. What was the cost of the watch before the VAT was added? So first of all, we work out what our multiplier is. It's increased, it's gone up in value by 20%. So the percentage multiplier is going to be the original amount, 100%, plus the 20% VAT. So the multiplier that we're working with is 120%. So what we're saying is 120% of the original is 84. We know the output, we want to work out the input. The way to do this without a calculator is, first of all, find 10%. So to change that to 10%, I need to divide it by 12, because 120 divided by 12 is 10. Now, in order to maintain the balance, if I divide that by 12, I have to divide this by 12 as well. So I'm going to do 120 divided by 12 and 84 divided by 12. So that tells me that 10% of the original is 7. Well, I don't want 10%, I want 100%. So to turn the 10% into 100, I have to multiply it by 10. To maintain the balance, if I multiply that by 10, I also have to multiply this by 10, which means that 10 times 10, 100% of the original is 70. So that means that the watch cost £70 before the VAT was added. How would the method differ if the original value had been decreased by 20%? Well, if it had been decreased by 20%, my multiplier wouldn't have been 100 plus 20, it would have been 100 minus 20, so we'd have been working with 80%. And after that, everything would be the same. So if I just go back, so if that was 80% here, I would be dividing by 8 to find 10% and then multiplying by the 10. So we're now on to progress check 3, and just a recap of some of the new topics that we've covered over the last couple of weeks. So compound percentages is another topic which comes up with a different approach if we're dealing with working with a calculator or a non-calculator. Today's is a non-calculator. So Sebastian leaves £3,000 in the bank for 2 years. It earns compound interest of 2% per year. Calculate the total amount Sebastian has in the bank at the end of the 2 years. So in the first year, The first thing we have to do is work out what 1% of 3,000 is, and we do that by dividing by 100, which takes off 2 noughts, so 1% is £30. If 1% is £30, 2% is going to be double it, which is 60. So that means at the end of the first year, in the bank account, he's got the £3,000 that went in at the start of the year, plus he's earned £60 interest. So at the end of the first year, in his bank account is £3,060. Now, when it comes to the second year, what it means is that the 2% interest isn't calculated on £3,000 now, it's calculated on £3,060 because that's what's in the account. So 1% of 3,060 divided by 100 is £30.60. We want 2%, so we double it, and then we add that value on to what was there at the start of the year. So at the end of 2 years, the amount of money in the account is £3,121.20. Go back and read the question carefully, because sometimes the question will ask how much interest has he earned, in which case the answer would have been £121.20. Other times it will ask how much is in the bank, and that's exactly what this question is asking. So the answer is £3,121.20. How would the method differ if the money was losing 2% per year? Well, it would differ in that we would work out the 2% in the same way, so we'd work it out as £60, but rather than adding it onto the 3,000, we'd take it off. So moving into the second year then, you would have £2,940 and repeat the process again. So read the question carefully. It's a grade B question, so it'll be in the second half of the paper. Is it an increase or a decrease? Area. Okay, it's a non-calculated paper, so you need to be able to deal with not only remembering how to find an area, but sometimes dealing with some tricky numbers without a calculator. So the rectangle has length 4.5 centimeters and width 2.8 centimeters. So to find its area, all we need to do for a rectangle is multiply the length by the width. So we have to do 4.5 times 2.8. Now you need to have a personal favorite method for multiplying up to 3-digit numbers without a calculator. Whatever method you choose is up to you. The one that students tend to like most these days is called the Chinese method. So the way that you set that up is you draw yourself a little box. This is a 2 by 2, so it's a 2 by 2 square. You run diagonals through the squares. 4.5, I'm going to put in as 45, and then 28 running down the other side. Then to fill in the squares, you multiply the corresponding digits together. So for this square, 5 times 2 is 10, 5 8s are 40, 4 2s are 8, which you write as 08, and 4 8s are 32. So that's what those red digits are. We then, starting at the bottom diagonal, add up the digits that are in red. So in this diagonal, it's just 0. In this diagonal, 2 plus 4 plus 0 is 6. In this one, 8 and 3 is 11 and 1 is 12. So we put the 2 down and carry the 1 over. And then in this diagonal, 1 and 0 is 1. To write down the answer then, we write down the purple digits, 1, 2, 6, 0. Because we aren't multiplying 45 by 28, but 4.5 by 2.8, we need to put a decimal point in the right place. The easiest way to do that is to estimate what you would get if you were multiplying 5 by 3, because that would round to 5, that would round to 3. 5 3s are 15, so the decimal point has to go in a place where this number is close to 15. So if I put the decimal point at the end, it would be 1,260, so that's no good. If I put it between the 6 and the 0, it would be 126. if I put it between the 2 and the 6, it's 12.6, which would make it as close to 15 as you would get. So the area of that rectangle is 12.6. You might be given a trapezium. Now, on the intermediate tier paper, it's one of the few formulas that you are provided. It's normally on the front, but I've forgotten to include it when I sent the papers for printing. So if the teacher could copy this onto the board so that the students can refer to it when they get to the question. So this is showing you the area of a trapezium is a half bracket a plus b h, where a and b are the parallel sides and h is the perpendicular height. It's the height which is not sloping, it's at right angles to the parallel sides. So what they've done here to make this confusing is they've given you all the sides and you have to put in the right ones. So the A and the B are the 7 and the 10, and the H, you've got a choice of 4 and 5. Clearly the perpendicular one with the right angles is 4. So the area is half bracket 7 plus 10 times 4. We insert a times when we put numbers in. So 10 add 7 is 17. So I've got a half of 17 times 4. Well, when you multiply, it doesn't matter what order you do it in. So because that's an odd number, the easiest thing for me to do is a half of 4, which is 2. 2 times 17 is 34. And the units, if it's a question where they explicitly ask you for the units, there's a mark for them. For area, in this case, it would be centimeters squared. If it doesn't ask you for them, there's no mark for it. Then we come to cumulative frequency, which is being tested in this paper. The cumulative frequency diagram shows the distribution of speeds for 60 cars on a road. So you can see here the speed is the horizontal axis and the cumulative frequency counts up to all 60 cars. Estimate the median speed. So the median is the middle average. The middle average for 60 cars is going to be at 30. So you go up to 30, read across and down. So we get a median of 60 kilometers per hour. Estimate the interquartile range. So we spoke in a previous slide with box plots about the interquartile range. It's the difference between the lower quartile. So the lower quartile, if there is 60, a quarter is 60, half of 60 is 30, half of 30 makes half of a half, which is a quarter. So that's going up to 15, giving me a lower quartile of 44. The upper quartile is at 3/4 of 60, which is going to be 15 above the median. So that takes me to 45. I read across and down. And you need to do this as accurately as you can. And as I've told you in class, you want to be drawing these on your graph so that the examiner can see you're doing the right thing. So the upper quartile is 70. The interquartile range is going to be the difference between 70 and 44, which is 26 kilometers per hour. The speed limit on the road is 85 kilometers per hour. How many cars exceed, so that's go over 85? So on my graph, I'm reading in the opposite direction now. I've gone to 85, reading up to the graph and across, and that's 56. 56 cars are within the speed limit. The exceeding cars are the ones that are between that point and the total number of cars. So in this case, that's going to be 4. And that's pretty much all the new topics that are being tested today. There are other things in the paper, but hopefully they're things that you've met before. So go ahead, smash that paper, guys. I'll see you soon.